Good afternoon, everyone. And I'm hoping I'm not going to bore you this afternoon. I've got a few challenges today, being one of the few last speakers that are going to be coming in for the afternoon. I'm not sure whether Eastern were playing mind games on me or not. It started in the evening yesterday, where Simon Thick says, I know who wrote your presentation, you know. Yeah, when I was talking to one of your team members, he says, no, Simon, I'm busy. I'm writing dinner presentation that he's going to present at the PWI Institute. I said, no, I heard that. It's fine. We go for lunch. Then Tom says, you know, I had a preview of your presentation. You know that slide there that Jade presented, which is Jade's slide? It might have a bit of contention. I said, no, I've seen it. What can I do? I meet Kathleen over lunch. And she says, you know, our model for Eastern, we did it in a different way, but what Dominic did for you is brilliant. So being in an academic institution, I have to own up to plagiarism and acknowledge a few. But I've got a team, Tom Banamo, who is our key lead in power distribution. I've got Jade Perry, who is working in the sponsorship program and aligning us to the future business world. I do have Felix Murphy, who is doing the number crunching behind the scenes. I've had the privilege to have a team locally to create a model. So what you see, if you see any familiar slides, is because we've decided for once we are going to have a single message that we're going to transmit to the industry. And that is helping because I think together we're strong. Let me just mention this before I go into the nitty-gritty of the slides. We are so interlinked nowadays in that, for instance, Gary, I'll be meeting next week. He asked a question. I'll have to see whether I disqualify him because he was saying we are already demanding more for less. But Paul, Atkins, Danny, and the rest of the teams, what we present either to the ORA or to indeed our own TA, we are demanded nowadays to have an independent review. And Peter has been working with us on hot weather. And arguably, I cannot stand here and tell an untruth because the industry is such that I will be exposed if any of what I'm trying to claim is not the right thing because the experts are here. And I'm glad I have to present in front of you. Having put those caveats, obviously, I will get into my main presentation. I won't dwell too much on this one because Kathleen has already delivered a lot of outputs around the kilowatt hour consumption of our train units, and we're still receiving more and more that are coming in, which is the 805s and the 807s that are coming in, the 730s that are being introduced. The EMUs are becoming more clever nowadays, and I would have given another presentation altogether for the stuff that we're harnessing from these new trains. But effectively what we're saying is there is a challenge here to the industry in general that at some point in time we will have an individual EMU monitoring system in terms of power monitoring and power quality and all those things and the stuff around electronics and the pollution, etc. of what we see. We're already seeing it in the 331s around our northern powerhouse. So effectively, what you see on that graph, it actually shows that we have got indicative values of what each EMU will actually get. But freight is the one that is frightening here because of the tractive effort that is required for freight. We see that we are into the 40 kilowatt hour mark and the 55 kilowatt hour mark. That has to be looked at in a very practicable solution. And again, I'll talk about biomodes later, which introduce a different system altogether that is a different challenge to the industry. This is one of the slides that I was told I was plagiarizing. You can actually tell that I'm trying to water myself down into showers as an engineer to try and explain to non-engineers what it means in practical terms. We're all in this communal shower that is here. It has to be pressurized enough for us to have a decent bath. The more we introduce other services and other systems within the system, our loading is such that we then actually have two deficiencies in the system, which is the capacity or the throughput of that piping system plus the effective voltage, which is the pressure that we need for things to function in the system. So what we are finding with the modern units, for instance, is they are more sensitive even to frequency changes and more sensitive to voltage changes to an extent that we do have those challenges around the areas in the infrastructure where we have a low voltage profile. That's why from a network rail northwest and central strategy, we are now looking at, generally speaking, connecting onto the 400 kV grid, because that's what we believe is reasonably right to do, from an AT system that we want to complete, which was started by many that I can see in the room in the West Coast Mainline route modernization days. And we followed up by trying to deliver the power supply upgrade projects, but we left glaringly obvious systems that if you take the documents from the Strategic Rail Authority that was there before it was subsumed into the government systems, we still haven't delivered what was thought about probably 3-4 decades ago. And that's the reality of industry. Where are we going? Today, as we see, those are the pockets of the grid system, which I call the AT system across the network. Where we haven't delivered yet are the red bits that we see. Walsall Rugeley is interlinking the West Coast Main Line to the Grand Junction lines, which is the piece there in the magnet, which is generally somewhere there. But effectively, further down, somewhere here. Effectively, what you see is those glaringly obvious red bits are giving us a challenge. I understand, obviously, again, I think everybody was attacking me. Our mates from SPL here, Mr. Skinner particularly, was very adamant that the AT system is not the best that we need because it introduces structural loading. But actually, in essence, what we see is connectivity on these networks because we look at alternative feeding arrangements. And that's where we fail for most of our systems in terms of where we are going to. And the green bits, which is further down south, is talking about stuff that we have, which is the basic rail return classic electrification, which is between Acton Lane and Euston buffer stops. I will not talk about DC and the AC-DC interface because we might spend another day on that even. When we then look at the landscape of what we see here, we see various train introductions that are coming into the system, and generally speaking, our load is increasing on the existing network. Whilst we promised, and I know, I think it's Jason that is going to talk about freight, the decarbonizing of freight has given us a challenge where the biomodes or the tri-modes, whatever they are, in terms of their primary output is they need to actually maintain the mainline speeds when they are in electric mode. once they are in diesel mode in inter-urban traffic and inter-use traffic, they cannot work effectively in their diesel mode, and therefore it affects the rest of the timetable. So in mixed traffic networks, they are expected to operate electric. And one of the challenges here that we haven't actually sussed yet is the fact that industry has sold freight paths to the freight community. I might be corrected here, but actually they haven't detailed enough and nailed down whether they will be electric or diesel. That's immaterial. So effectively, once we accept one into the system, we have accepted all. So our decarbonization efforts, therefore, have to look out at the global picture of what is going to be coming in the horizon. We then start an interesting outputs here in terms of services for electrification. I won't go through the individual ones on these ones, but you can actually see that we're adding more, and we're adding more, and we're replacing the Voyagers for the 807s and the 805s in this case. And as we add more, we are looking at the TransPennine and the weekend service, etc. It's interesting that we were competing, obviously, with Simon and East Coast. I'll come back on that one shortly. That is, TransPennine project and programs are now actually linking us east to west, which is an interesting dynamic because we can have diversionary route capability. We had never looked at that in the industry before, that we cannot close the West Coast Main Line and close the East Coast Main Line at the same time. So by so doing, it means, generally speaking, integrated planning and the east-west electrification provides a benefit to the industry, not only in terms of actually the north-south traffic, but actually the diversionary routes that we can actually have the blockades that we need to deliver outputs in the industry. So that's where the interdependency now is there, because when I come to present something, they say, what is Eastern's view about what you have presented? And what is Great Western's view about what you have presented? I'll then go further. This one is a scary slide to most people, but possibly it answers an industry problem that we have, that depending on the remit that one has been given to decide on what they need to comment on, they will comment on that only because that's what they have been remitted to. But actually, when you then see the elements here, that the whole industry strategic plan, for instance, we looked at, it was actually decarbonizing, but it didn't look at the decarbonizing of freight. We looked at the freight parts that have already been sold. Most of them are not being used, but they are used occasionally, but we can't retrieve them so that we put additional stock, because then we get a problem. We look at the class 93s and the 99s that we actually had highlighted before, that once we accept one, all are accepted. What do? We look at Viva Junction. And the center of this is what Gary was asking about in terms of why does the route asset managers actually ask for more infrastructure for less? But we're now finding out more and more that the current infrastructure that we have, and particularly our oil-filled switchgear, has come to capacity, and we have overstrained it over time. So with the increase in load, we're coming to a point where we are saying something needs to be done to that kit. And hence our CP7 plan says we need to renew the K11 infrastructure, starting with the mostly used routes, so that we don't change oil every 30 operations, so that we don't actually change all the stacks and every contact or inspect it further. So it now becomes a safety burden and a maintenance burden. So we are now integrating our renewals plans into enhancements. The challenge that we face here is, generally speaking, the areas around crew. Some of us here were there when we attempted to do the Weaver 80, Weaver to Whitmore. We didn't do it, so we didn't complete the electric spine with 80. We now are suffering the bits on all the traffic that is starting from crew. And we're suffering low voltages, including the Caledonian slipper if it goes through that way. The challenge here that we have is the measured voltages are now telling us, because we have now metered the system to death, but it gives us the evidence as to why and what we need to do to manage the infrastructure. So generally speaking, I will not deal with the detail here, but we need to fine-tune the timetable. I saw some slides here on the timetable fine-tuning, but the challenge that we have again is freight is timetabled, but it has got a plus or minus 30 minutes window. So the signaler has to make sure that they accept that piece of freight into the network. So generally speaking, how the network behaves, therefore, becomes a challenge for us. This was one of the contentious slides that I think Tom highlighted. He said, Tochi, how can you actually look at circuit breaker operations and then you start looking at the problem that you're facing? AH5, which is the top one there, it's okay, I'm fine for now because it's an FSK circuit breaker, which is a vacuum circuit breaker. The second one, which is AKHM14, and the rest of them that you see there. Arguably, if there are K11 circuit breakers, oil-filled, I have to filter the oil or change it every 30 operations. And what is happening with freight nowadays is once a double-headed class 90 runs through, you have a single-ended trip. And because the circuit breaker doesn't know whether it was a load tripping or otherwise, my maintenance standard says for the thing not to blow up, go and change oil or filter. Yet in normal practice, if nothing has tripped, I have to change every 2 years. So it's now becoming a maintenance burden, which now is calling for us as an industry to look at a collective view of how we then manage the present infrastructure while it's looking at bringing capacity in our renewals to make sure we are not renewing like for like, but we're actually renewing with the most capable, looking at the enhancements that are coming into the future. I'll look at then the long-term trends. What you see on your right is generally the 400 kV or 275 kV transmission network. And that grid transmission network is the one that we want to utilize as a strategy for the spine that allows us to actually push for the auto transformer system within the south to north element of the West Coast Main Line. Then what we do with the other sub-routes, which is one thing that we haven't actually said. There is a balance here of the number of substations that we can have. Currently with the JOS, we are paying 250K, round about that figure per year, per supply point for the national grid to provide us with that connection. So the more the substations on the OPEX element, you are still paying a magnitude. So when you are looking at the overall cost of 80 and the reduced number of substations, yes, there may be some equipment that comes in with it. We have to actually balance the ongoing maintenance and the ongoing industry costs that are coming in with those connections. So it's not a simple output. For the Northwest, we're at the Mark III system with the AWAC, which is the aluminum conductor, which is reinforced with steel. It is actually showing some signs of significant wear. And part of the problems with the system in terms of pressurized system with AT is we increase the fault level to 12 kA instead of 6 kA. And by so doing, it means we want to push more energy into the system, and therefore we have to then upgrade, apologies, all you overhead line conductors, the strings that connect the substations. I've already apologized in advance. I want to be inclusive. What the problem is with that system is sometimes we upgrade equipment that still has got several years to go. And the key challenge that we have there is the electronics that we had in the presentation here. We are now asking the industry, with the breakthroughs in SFCs that have happened in Eastern, can we have an electronic intelligent fault limiting reactor that will allow us to operate at 6 kA and it clamps the fault current to 6 kA? And that's what we are challenging ourselves and industry with, to say from an asset perspective, yes, it is the right thing to do, but some of the elements that we are doing in terms of trying to upgrade, we need to help ourselves. It's an interesting one here. I'll put one of these quotations from the Lambrick report. One of the investigations reports, I'll quote it so that I don't plagiarize. It says, we have developed a culture as an industry of self-helplessness, that we don't feel it is our problem. We don't feel it is our issue. And therefore, as long as if I push it to the project, that's fine. As long as if I put it to the asset manager, that's fine. As long as I push it elsewhere, it's fine. But that's why we are here, and these great institutions are here, so that we put our minds together and we see from history what has worked, what has not worked, and then we start actually developing ourselves to a state of self-help. The grid transformer is towards my right. Apologies, these images were taken in Richard Wales' days, way into the 2000s, if you know them. That's the lump of steel that we have and oil that the national grid provides. The bit in the middle is our fault limiting reactor, where we are saying we just need to put something in there to limit the fault current from about 15 kA or kiloamps to 12 kiloamps. And that's the bit there that I'm saying actually we should do something maybe with the SFC technologies that will allow us to clamp those fault currents to 6 kA. Then we may not actually upgrade as much of the infrastructure that we are upgrading now. So effectively, that's the balance that we have. We do install, obviously, conductors on the system, and the conductors here, AT, push us to replace the signals. That's one end. They push us to probably change the way we maintain, because some of the AT systems will be out of boundary. But actually, arguably, we are trying to run as many trains as possible and limit the number of substations and simplify the technologies to the best of our advantages with the technology that we have currently. Strategic need. This one is an interesting one. I'll go on to these bits here because I just have to probably finish off what we need to look at here. For us, for the West Coast Main Line, is to renew generally what is marked in red. Some people would say, why would we need to renew the bits in red in the middle there, which is around the Midlands? But interestingly, what happens here now is if we close the Trent Valley lines anywhere close to Brereton because of a fault between Rugby and Brereton there, we divert all the traffic to Scotland via the West Midlands. And you know what? We can't support the load. So the diversionary route capability becomes a must. Then that says we need to make sure that the Birmingham area is reinforced adequately. So it goes up north. Here in Blackpool and the Preston area, it will actually affect TRU and everything else that we do going into the Scotland borders. So at the moment here, I will disclose that we are trying to introduce, as part of the control and managing this presentation publicly and managing power systems capability with the system operator, we're already saying we're declaring congested infrastructure, not from a timetabling perspective, but from a power system perspective. And that's how serious we are now taking this to the next level. We have secured funds out of RNEP to introduce Penrith, a substation in Penrith here. We call it Penwetham, but it will have another name. But the DFT have actually acknowledged that that is required for the HS2 services that will be coming into the future. But even before the HS2 services come through, we do need to then make sure we have that power supply. Otherwise, the power in that area is giving us a problem. I'll have to say this in one of the areas here. There are some things that are required for HS2, yes, but actually for the existing timetable and the decarbonization, there are renewals that we need to deliver as an output. So what we will find is in CP7, there will be a renewals contribution because the asset is old, but there will be an enhancement piece that has to be agreed on so that we meet in the middle. And that's the way we are now trying to do and to build this strategy as it stands. This one will take 2 minutes. Right. Power system capability report, as what Eastern have already highlighted, we now have it. We now have it. The eyes have it. Anything that is red means, generally speaking, we have come to a point where we can't do anything except to intervene. Anything that is yellow, which includes most of the Manchester area and the Transpennine upgrades and etc., it then comes in to tell us that we are at risk. We need to upgrade the existing systems at Weaver so that at least we boost it into full 12 kA. You can see in green there and dotted, I'm actually expecting the TRU and everybody else that is in TRU to complete the Hay Road and the Staley Bridge area there so that it all becomes green. Let me go on to the next one. South of the river or south of the system, we've already talked about Birmingham, which is again red, which means there is interventions that are required. Interestingly, we're coming to Acton Lane, where most of those feeders that we were talking about trip every time. This is the inner London area, which briefly I will explain because this one is my last slide. It links with the works that are happening in Crossrail and the works that are happening in Anglia. So we feed the Anglia bit from the West Coast Main Line. If we lose one feeder, we are now actually overloading the single feeder to about 1.5 times. And if it trips, because it trips actually to the supply end of the system, it then gives us a challenge that National Grid, or in this case UKPN, says there is a problem that happened in your system, let's investigate. And closing the 4-track railways for 10 minutes while they investigate before they energize, it costs the industry between 500K and 1.5 million, 10 minutes. And once that happens, it stops services from as far as Scotland because there will be congestion further down south, so they are not dispatched on the West Coast Main Line. That's our challenge. So key to it is there are things that we need to do, that we need to deliver. Key to it is we cannot do it alone. That's why I've plagiarized the presentation so that we know it's public knowledge now, and you now have got guilty knowledge that I've told you what I've told you. I was told to come and tell you. But I just need to close with one sentiment that comes from a Jedi that is from the East. He says this: I returned and saw that under the sun, firstly, the race is not for the swift, nor the battle to the strong, nor the bread to the wise, nor the riches to men of understanding, nor favor to men of skill. Then he summarizes his statements and says, but time and chance happens to them all. This is our time as an industry. We are only but filling the gaps of those that went before us. And as such, the next generation will be depending on us, and we're going to be judged as to whether we are successful or not. And ideally, we do put a lot of badges here that are Network Rail, Atkins, SPL, whoever. But all that are listening to me here are well-accomplished railway men. And divided, we will never make it, but combined, we will make it. Finally, apologies, I won't be very exclusive or inclusive, but effectively, as an industry, we should learn not to compete, but to create space for each other. And that's my last words. Thank you so much.